Thank you very much. This week, we are going to look at our previous, the revision that you have been doing at home. And today, I want us to begin with the week one questions. I marked your books and I realized that there are a lot of weaknesses. So let's look at the week one Monday questions. It was about properties of matter. Let's go through number one. Question one was asking, what is a solute? What is a solute? The answer that you're supposed to write was, a solute is a solid that dissolves in a solvent. A solute is a solid that dissolves in a solvent. So we said that we have those kind of solids that if you put them in solvent, they dissolve. For example, salt. If you take salt, you put it in water, salt will dissolve. Therefore, a solute or solutes are those solids that dissolve in solvents. Remember, solvents are liquids in which these solutes dissolves in. Number two, liquids that mix completely are called, the answer was supposed to be mixable liquids. Remember, we said we have two types of liquids. One is mixable liquids, and then number two, a mixable liquid. So mixable liquids are those liquids that are able to mix completely and form a uniform layer, or we call it homogeneous mixture. While those ones that are not mixed, that cannot mix, we call them a mixable liquids. Number three, what is solubility? That was question number three. And very most people were not able to answer this question. What is solubility? We say that solubility is the ability of a solute or a solid to dissolve in a solvent or in water. So the ability of a solid to dissolve is called solubility. So you have to answer that question that way. Then number four, we talk about name 4 methods of separating mixtures. If you can remember, we talk about 7 methods, and you can see them. We have decantation or sedimentation. We talk about filtering, hand picking, evaporation, use of magnets, winnowing, and also sieving. I think we discussed all this last week, and you can refer to your lessons that we learned the week. Let's go to the next question. And this question, I don't know why most of our pupils failed. Let's look at number 5. Solids that do not dissolve in water. Remember, we have said that we have those solids that are able to dissolve in water, others are not able to dissolve. Therefore, solids that do not dissolve in water, we call them insoluble solids, or we can say insoluble solids. So those solids that are not able to dissolve, we call them insoluble. The ones that are able to dissolve are called soluble. So number 5, just right. You have to write insoluble solids or insoluble solids. If you could have written all those two alternatives, I could have given you the right, I could have given you a mark. Let's look at number 6. Number 6, no one did. In fact, only one person attempted number 6. Let's look at number 6. State any 3 ways of increasing solubility. If you want to ensure that a solid dissolves in a liquid or in a solvent, what do? We have 4 ways in which one can increase this. One is by stirring the mixture. For example, you want to put some sugar in your tea and you want it to dissolve very fast. What do? You simply take a spoon and you stir. So through stirring, you are able to increase the solubility of this solute in a solvent. Apart from stirring the mixture, we also have by increasing the temperature of the solvent. For example, you are making tea. For that sugar to dissolve very, very fast, ensure that the liquid is hot. When the liquid is hot, it increases the solubility of that solute in a solvent. So by increasing the temperature of a solvent, let's say by increasing the temperature of water, sugar is able to dissolve in water very fast. Number 3, by reducing the size of the solutes. For example, if sugar particles are very big, if the particles are large or are bigger, they will take time to dissolve. But if they're crushed into smaller sizes, then the rate at which it dissolves will also be higher. So if you want to increase the solubility of these solids, ensure that the size particles of this sugar or salt, any soluble solute, ensure that their sizes are reduced into smaller particles. Then lastly, we have by increasing the amount of solvent. Here should be solvent. Okay. So if you realize that you have little water, for example, you want to mix sugar and water, and you realize that it takes time to dissolve, you simply need to add more water. If you add more water, that's what we call the solvent, then they will dissolve very fast. Because if the solid or the solutes are higher than the liquid, they will not dissolve. So to increase this, you simply add more water or more solvent to ensure that they dissolve. So check at number 6 and please ensure that you write those answers correct, the way I've done them there. Let's look at number 7. Number 7 was asking, what are immiscible liquids? What are immiscible? So remember we said we have mixable and immiscible. So immiscible are 2 or more liquids that do not mix at all. They don't mix, okay? If you put them together, for example, take paraffin and water, put them together, you are going to form 2 layers. So water and paraffin are immiscible liquids. So you are supposed to say immiscible liquids are 2 or more liquids that do not mix at all when put together or when put in one container. Let's look at number 8. Number 8 was asking about materials that are attracted by a magnet. I think this is a very easy question, and some of us failed in this question. Now, materials that are attracted by magnet, we call them magnetic materials, while those materials that are not attracted by magnet, we call them non-magnetic materials. So we check on that. It's a very easy one. Ensure that you do that correction very well. Number 9, Akinyi accidentally mixed salt and flour at the stages she would use to separate the mixtures. Remember, we said that you have factors that determines the type of separation or the method of separation to be used when you want to separate mixtures. So here we have two items. We have salt and flour. Remember, salt is able to dissolve in water, while flour is not able to dissolve. Therefore, because of solubility, which method we use? We have 2 steps to be followed here. Number 1, take all these mixtures, salt and flour. Remember, it is one mixture now. You want to separate them. The first thing you do, dissolve them in water. When you hear the word dissolve, meaning put them in water and ensure that you stir so that they dissolve. Now, when you dissolve this in water, you realize that is only salt that will dissolve. Maize flour will remain because it is insoluble solute or it is insoluble solid. So after that, you decant. When you are decanting, you are going to remain with your maize flour as a sediment. Remember, as a sediment. And then you are going to have a salt solution as a clear liquid. But at the same time, after decanting, then you do the filtering, okay? So you dissolve, you decant, and then by the time you are doing decanting, at the same time you filter, okay? So when you realize, when you do the decantation and filtration, this can go together. Filtration we are doing to ensure that at least all the maize flour are left in the one container. So you are going to have your, we have now the 2, we have filtrate, okay, salt solution as a filtrate, and then in the other container, you are going to remain with our residue, which is now the maize flour. So you can see we have separated maize flour by decanting and by filtering, okay? So we have left with salt solution. What do we do with the salt solution for us to remain with salt? We simply evaporate. So if you evaporate, remember we said that during evaporation, it is only one substance that is going to be recovered. Water is going to evaporate, and then you are going to be left with your salt. So Akinyi had to go through this 4 process to ensure that she gets back her salt and her maize flour. Dissolve, decant, you filter, and then evaporate. Otherwise, if you wrote any shortcut, then you are wrong. So you can go through those and ensure that you write the correct answer. Let's look at number 10. Number 10, let's look at number 10. That was Monday. Number 10 was asking, write two components of air that when put together forms 99% of air. This is a very easy question, but we did not think. Which two components of air? Some people are writing very funny answers, but to summarize this, we have nitrogen, which is making up 78%, and oxygen, which is making a part of 21%. So if you add 78 plus 21, you will get your 99%. So we add nitrogen and oxygen. These two components, if you put them together, you will have your 99% of air. So look at the way, it was very easy one. A very easy one. So ensure that you write the correct answer. So that was all that we had on Monday. What? Let's look at on Tuesday. On Tuesday, which states of matter expand most? I've given you the list of this matter on how they expand. Okay. Now, the first one, we have the gases. Gases expand most when heated, followed by liquids, and then solid expand the least. Okay. So check on your answer and ensure that you write in that order. I've written this in order. Gases expand most, liquids expand moderately, then solids expand the least when heated. So it will just like that. Number 2, name 3 uses of carbon dioxide. You're supposed to give us 3 uses of carbon dioxide. I've given you the 4 of them. 1, carbon dioxide is used by green plants during photosynthesis. When they are making their own food, they use carbon dioxide. You know that? Then we have making dry ice by sublimation. When you want to make the dry ice, we always use we use carbon dioxide. Remember, sublimation is where the gas changes direct into solid without passing through the liquid. So through that process, we can use carbon dioxide when making the dry ice. We shall look at that. Then number 3, preservation of food, because it does not support life. You know very well that how do we preserve food? We preserve food by using carbon dioxide, isn't it? If you open a soda, you hear that sound. That is a carbon dioxide. So now, when these foods are being preserved, we always use carbon dioxide because carbon dioxide will never support life. Therefore, there is no bacteria that can survive in the presence of carbon dioxide. So you can use carbon dioxide when you want to preserve food. Then finally, in making of fire extinguishers. We know very well that carbon dioxide, they don't support burning, okay? Therefore, in presence of carbon dioxide, there is no burning that will take place. Therefore, when you want to make fire extinguishers, we are using carbon dioxide. So I've given you 4 uses of carbon dioxide. Ensure that you look at those, okay? And then let's look at number 3. Number 3, you are asked, write down any 3 characteristics of solids. I've given you almost 5 of them. They have definite shape. They have definite volume or size. They have definite mass and weight. They have they contract least, especially when cooled, okay, or on cooling. And then solids also are able to transmit sound better as compared to liquid and gases. Remember that, you said that sound travel faster in solids as compared to liquid and gases. So all those, I think this question was well done by most of the pupils. There was no serious issue there in that number 3. Now let's come to number 4. Number 4 is asking about, list down any 3 states of matter. Look at this. This is a very easy one. Down, we have 3 states of matter, isn't it? We have solid, liquid, and gases. So it was just as simple as that. There is nothing you can add on top. Number 5, what is matter? What is matter? A very simple question, but some of us were not able to answer this. Matter is anything that occupies space and has mass. Just as simple as that. Matter is anything that occupies space and has mass. That's the definition of matter. Number 6, solids change into liquid through the process called, we are going to look at that. We have some diagram we are going to do. But for this number 6, the answer was melting. When you heat a solid, for example, just take a quick oil, cooking fat. When you heat cooking fat, the cooking fat will melt and become cooking oil. So cooking fat is a solid, while cooking oil is a liquid. So that process is called melting. For another example, take ice. Okay, this ice that you always eat. Okay, when you expose that ice into air, okay, because you have heat on air, that heat will expose. When you expose that ice to that heat that we have, the ice will melt and become liquid. Therefore, that process is simply called melting. Number 7, when a liquid is heated, it changes into. So if you heat a liquid, it is not gas. You can just say a vapor. So I was awarding these two answers: a gas or vapor. But the correct answer number was to be a gas. Why are gaps left in a railway line? Very few pupils were able to get the right answer. Now look at that railway line. I've given you this railway line. For those who have not seen the railway line, this is a sample of that part. There's always a gap here. There's a gap somewhere here, which is being left between these two roads, okay? Now, you know, when the trains are moving and the train are moving along these roads, okay? The roads, those roads are metallic. Therefore, we know very well that when metals are heated, they expand. The friction between the railway wheels and the rods creates some heat. Therefore, these rods expand, okay? And when they expand, they can explode, okay? So to avoid that explosion, some gaps are being left there so that when they expand, at least they will still have some space to occupy. Otherwise, if those gaps are not left, the railway line will explode and that will cause accidents. So to avoid such accidents, those gaps are left there. So why do we leave the gaps? The gaps are left to allow expansion, as simple as such. Let's count number 9. Number 9 was a very simple question. I don't know why most of us were not able to answer this. Number 9, name any 3 leguminous plants. When we talk about leguminous plants, we are talking about dicots, okay? So these are dicots. We have beans, peas, peanut, green gram, groundnut. You can name them. So that was for that. Then Tuesday, number 10, which was the last one, you were asked that plants that convert nitrogen into proteins have swellings in their roots. How do you call these swellings? Look at this. This is what we call the leguminous plants. They always have those swellings, and those swellings are called root nodules. Now, it is these root nodules, if in those swellings or the root nodules, we have some bacteria, and this bacteria, they are able to fix nitrogen from the atmosphere, okay? So we call them nitrogen fixing bacteria. So in the root nodules, we have nitrogen fixing bacteria. There are bacteria that are able to fix the nitrogen from the atmosphere into the roots. And then this nitrogen is being converted into what is called nitrate salt. And then this nitrate salt is used, okay, by these plants as their food, okay? So you're supposed to write the answer there as the root nodules. Root nodules. So that was on Tuesday. Let's look at what we had on Wednesday, and that will be the final. Wednesday, inert gases are also called. I gave you there all the names. You can call them rare gases, inert gases, or other gases. All those 3 answers were accepted, and you could have used those ones. Number 2, which gas is necessary for seed germination? Remember, requirements for seed germination. We need 3 things. 1, we have air, and which air is that? Oxygen. So the air that is required during seed germination is oxygen. Apart from that, we also need moisture or water. Then we have warmth. Warmth is a temperature that is favorable, that can support the germination. So you are right. In this question number 2, the answer was oxygen, because they asked which gas. So the gas that is required here is oxygen. Let's come to number 3, very, very fast. Number 3 was the gas used by green plants to make their own food is called. So they're asking you which gas is required during photosynthesis. That was what the question was asking. Now, the requirement during photosynthesis, we need what? We need carbon dioxide, which is the gas. Apart from carbon dioxide gas, we require water, we require sunlight, and we also require chlorophyll. So apart from just a gas, carbon dioxide gas, you must also know other requirements. So we also need those three other requirements. Let's look at number 4. Number 4 was asking, I don't know how it was asked there, but I've given you, I think they were asking which gas is used in bulbs, okay? Now we have the uses of rare gases here. We have the argon. Argon is used in electric bulbs because they don't make or they prevent the darkening of the glasses, okay? That's why you can see the bulbs are, they keep on burning every day, but you will not see such kind of smoke or dark smokes because we have the argon gas that prevent that darkening of the glass. So argon is the one that is used in electric bulbs. Apart from argon, we also have the neon gas, which is used for advertisements. If you go to towns, you will see those billboards, okay? And the billboards, they look like the televisions, they're showing pictures, they're showing writings. So we have the neon gas that is used there for those advertisements. Then we have the krypton, which is used in the camera flash. And then we also have the helium, which is used to fill the hot weather balloon. So all those are the uses of the 4 rare gases. Number 5, very, very fast. In how many forms does matter exist? I think we have answered this. We had answered this before. We said that matter exists in 3 forms. We have solid, gases, and liquids. So here you are supposed to write 3 forms and just leave it like that. Let's look at number 5. Use the diagram below to answer the question that follows. So this was the diagram. Very, very fast. This was the diagram. So look at that very fast. Now I have summarized this so that you can know these parts. Now part W is changing of solids to liquid. We call it melting. Then liquid into gases is evaporation. Gases into liquid is condensation. And then liquid to solid is freezing. So I think I have summarized all those. And therefore, let's come to the questions so that you can see. Now, which process is represented by letter Y? I have said that letter Y is called condensation. So the answer there was to be condensation. Let's look at the next question. Which 2 processes involve a decrease of temperature? A decrease of temperature. So during, we need cooling during condensation and freezing. So you have to write condensation and freezing. You could just write Y and Z, okay? Just write Y and Z because I believe you know what Y represent and Z represent. And then number 8, which 2 process involves an increase of temperature? That is melting and evaporation. You could just write W and X. Let's look at the last, or number 9. Number 9 was a very simple question. I was asking you, what is condensation? Look at this, very simple. So the condensation is the process through which gases changes into liquid due to decrease of temperature. Just simple as that. And then finally, number 10 was asking you, write down the correct order of changes of states of matter. This is what I expected you to write. And there was no shortcut. Okay. You have write solid, liquid, gases, and then write all those melting, evaporation, condensation, and freezing. And that was almost 4 marks. So check on that and please ensure that you write what is appearing here. Otherwise, I want to stop there. We shall proceed with other questions on Thursday and Friday, week 1, and also until we go to the last question. Otherwise, keeping on learning and have a blessed day.